Yes, good afternoon to everyone, and very happy to see you all joining our special VACCELERATE lunchtime webinar today. Professor Joe Schmitt kindly agreed to hold today's presentation about acute respiratory infections and the VACCELERATE SMAC5 investigation. Joe worked as Professor of Infectious Diseases and Vaccine Development and as Vice President and Global Lead Viral Vaccines for Pfizer. He was chairman of the German Vaccination Advisory Board for 12 years and is now active as editor-in-chief for Global Health Press and as scientific advisor for VACCELERATE. I hope you enjoy the webinar that will not only tell you a lot about infections, but also about the importance of the VACCELERATE Volunteer Registry. I'm putting a flyer about the registry in the chat and would be very happy if you would help us spreading the word. Please make sure you're muted during the presentation. You're of course welcome to ask your questions. Please put them in the chat and Joe will answer them after his talk. Of course, you're free to use your camera and microphone to discuss when your question is in turn. Joe, thank you so much for being here today, and the floor is yours.
Thank you very much, Janina, for the kind introduction, and welcome everybody. I'm curious why you want to participate in this webinar today. I guess respiratory tract infections is something that most medical students have not heard much about during their student time in medicine. But I guess once you're out in your professional life, you don't dare asking simple questions. And that is why many people don't really understand a lot of the basics of acute respiratory tract infections. My talk today is a little bit split in two parts for this reason. Number one is some basics for understanding respiratory tract infections. And that should then explain why our current MAC5 program is so exciting. Let me start with some very basic epidemiological data on diseases of mankind. This is data from the United States, where the American Army after World War II had enough money to send nurses into a 3-digit number of families every week for 3 years, for 3 consecutive years. And they were asking every week in the home of the families who was sick and what was the illness. So from that data, from that time, we learned that on average, humans become sick 10 times a year. Out of this 10 times you are sick a year, 6 times it's acute respiratory tract infections, ARI. The next most common cause of diseases or group of diseases is diarrhea. And that is only a quarter of what it is in respiratory tract infections. Such a study, to the best of my knowledge, has never ever been done thereafter. And that's a shame, because this is data before anybody seeks medical attention. And this is important. Respiratory tract infections happen out there, and only looking at the tip of the iceberg, only a small fraction goes to see a medical doctor. And this is why the epidemiology of many infectious diseases is not correctly written up or known in the current literature. The question is now, why are respiratory tract infections so frequent? And here is the answer. Once you start coughing, then you spread the organisms. Infectious diseases are called infectious because they are transmitted easily, and the airborne transmission is the most effective way to transmit any pathogen. This is a slide from the New England Journal of Medicine where a physician tried to intubate a patient. He did intubate the patient. And what you see here, these white spots are particles that have been transmitted from the person who was intubated. And this is a person who was not coughing, right? At the time you're intubated, you are under narcotics and you don't cough and you don't breathe much and not very forceful. And still, this is the way you look like after an intubation. And this material you will inhale. And again, very high transmission rates of respiratory tract infection. Next point is some basics on the epidemiology of respiratory tract infections. And this leads us to Longyearbyen, which is north of the polar circle. Spitsbergen is the main city there. And this was a city that is well known for charcoal mining. And what you see here in these bars is the number of respiratory tract infection cases. So what you see, they start when the temperature, and that is the brown line here, goes up. Acute respiratory tract infections in the polar circle occur in summer, not when it is cold. This is the cold time, right? Week 1 is January. Low or very, very few respiratory tract infections. The bulk of respiratory tract infections is in summer. Why is this? Well, ships arrived in Spitzbergen only in summer because Spitzbergen and Longyearbyen was closed by ice. You couldn't go there. There was no plane in these times. You could only go there by ship, and the ships came to pick up the charcoal that was mined and bring it back to continental Europe or the United States, I don't know. Once the ships came, they brought influenza, RSV, whatever they brought, and then there were a huge number of infections, and then they settled down a little bit, and they disappeared again in winter, because the population in Longyearbyen is roughly 2,500. And after a while, everybody has had influenza, RSV, you name it, and then everybody is immune. There is no longer any susceptible person, and influenza disappears. The lesson learned from this is each pathogen, each respiratory pathogen has a specific number of population size that is needed to maintain susceptibility. For measles, this is 200,000. A population of less than 200,000, nobody coming in, they will not have measles because measles will be eliminated just by the fact that everybody will be immune after a while. And again, for influenza, I don't know this number, but you see here 2,500 is not enough if you live together in one population. The influenza disappears just by being there on this island and everybody is immune. The next term to learn then is, for this reason, common cold is no diagnosis. And if you studied medicine, you should avoid the term common cold. And in German, you should avoid the term infect. This is layman terminology, and basically it tells you, whoever tells you you have a common cold did not fully examine you. Because if you would be examined, a doctor would tell you, what is the organ that is infected? That is the minimum. Do you have bronchitis or pneumonia, or just conjunctivitis, or whatever, otitis media? Ideally, you would name the pathogen and the underlying disease or the exposition. And this is what, I guess, for respiratory tract infections is really simple. You take the lower respiratory tract, bronchioli, then the alveolar duct, alveoli, trachea, bronchus, bronchioles, this is it. And this stops here. The lower respiratory tract is anything under here, the glottis, and everything up there is the upper respiratory tract. As a principle, upper respiratory tract infections, that is simple, that is usually not life-threatening and not much to worry about, with some exceptions, but that is the basic rule. So if you diagnose a common cold in the future, you don't say common cold, but upper respiratory tract, which means you examine the patient and you exclude there is a lower respiratory tract. So this is one, we have now the organ which you can diagnose by getting the history of the patient and by examining the patient. Now the pathogen you can diagnose by looking at the underlying disease. Pseudomonas aeruginosa pneumonia, and this is pneumonia only, you get if you have cystic fibrosis, you're on a respirator, or if you have neutropenia. And here you see why it is important to name the underlying disease. Neutropenia and Pseudomonas aeruginosa pneumonia means you're going to die unless the granulocytes return. Whereas if you have cystic fibrosis, you have a very good prognosis. You will survive the episode of pneumonia. It may recur, but you will survive. So it is always important to name the organ, the pathogen, and the underlying disease. This does not apply for acute respiratory tract infections because they recur every season, and you are susceptible after one season or later than one season, and you can get the infection again. Now let's look at the pathogens. What you have to understand here, number one, there are colonizing organisms like Streptococcus pneumonia, and all these here are beta-lactam susceptible. So these are treated if they do cause pneumonia or whatever, otitis media, this is beta-lactam indication. Then there is a second group of non-colonizing bacteria, and this is macrolide-sensitive bacteria, intracellular, for example, or not entering any cell at all, like Bordetella. It's Chlamydia, Legionella, Mycoplasma, and Bordetella. And finally, the group that interests us today is this group here of epidemic viruses, including SARS-CoV-2, RSV, influenza, AB, parainfluenza, human metapneumovirus, enterovirus, rhinovirus, adeno-rheo, and epidemic coronavirus, which have been known since the 1960s. And they have these funny short-term laboratory names, which I never can remember, but there are 3 or 4 of them that can be detected. This is the basic principle, and in 1995, I started to develop a multiplex PCR, and we had a respiratory network to detect these pathogens, including the epidemic bacteria. And I want to show you some of the results for some later learning. What you see here is from July 1996 to 2005, the different pathogens, and you see there are winter outbreaks, and let's concentrate on RSV in this violet color. What you see here, it started in 1997, and then there was a big low period, and then it comes up, and then there is a short low period. Long, short, long, short, long, short. So RSV has a pattern, and we were able to predict the RSV outbreak every season with a precision of 2 weeks. RSV outbreaks are predictable, and that is important because the one and only therapy for RSV is a very expensive monoclonal antibody that is given to high-risk children. And you can stop, you can delay giving this monoclonal in the even years, and you have to give it longer than in the following summer season. And sometimes you have to give it even through summer, but in the next year you can stop early on. So it is very important. One other thing to highlight here, parainfluenza 1 comes only in uneven years, and it covers the gap. Green, no green, green, no green, green, no green. Very interesting. So you see what you can do if you know what is going on in the respiratory season. You can make predictions, you can detect patterns, and much more. I will show you that later. One other point, lastly, why do vaccines against respiratory pathogens that are non-colonizing, why do they not work well? That is true for COVID, it will be true for RSV, and it is definitely true for influenza. And that has to do with the fact that these organisms have a high frequency of antigen variability. COVID is the hero here. That is the one with huge number of antigen variabilities throughout one season even. RSV, we probably get infected every 3 to 5 years, but nobody diagnoses the disease. There is very little data out there in the general population. And then influenza, I guess, roughly the probability that you are infected with the influenza virus is probably 30% per year, I would guess. So this graph only shows you where we are with vaccines and why vaccines work or do not work. Practically most, if not almost all good working vaccines are in the top right corner of this quarter here. And they work with antibodies, and they have a low antigen variability. And these vaccines here, particularly the PCVs and the MenACWY conjugate vaccines, they reduce carriage, acquisition, and colonization. That is why they work well. And these vaccines do not. And this is a nice way to explain where we are with vaccines, but this is another lecture at another time. Now, we have this MAC5 test. And again, we are looking into different pathogens. And this slide is only to remind me to say that there's almost no mucosal effect and therefore almost no herd protection for any vaccine against all these non-colonizing respiratory tract infections. probably also Bordetella pertussis, you do get repeated infections, probably every 5 years. And the reason is not that you have good immunity that protects for 5 years. The reason, I think, is that epidemics of pertussis only recur every 3 to 5 years. So this is the main reason, and it is probably the pertussis vaccines are far from being good vaccines, but this is still another point. Now, I talk about VACCELERATE. VACCELERATE is the network in Europe. It is the largest clinical trial work for COVID-19 and other vaccine trials with 31 partners in 18 European member states. And it was well funded by the European Commission as part of their pandemic program. And it is the entry point and connection for vaccine developers, for networking on vaccines and vaccination infrastructures, the European Commission, and all the various stakeholders when it comes to prevention of pandemics. Within VACCELERATE, there is this volunteer registry, which exists and is activated in 22 countries. Activation process is ongoing in 3 countries. There are cooperating registries, and the total number of volunteers to date is more than 100,000, and 40,000 roughly alone of these are located in Germany. We took advantage of this by sending a rapid antigen detection test, or MAC5 test, to 2,000 volunteers in this registry, and we told them to swab themselves and to run the test on their own, like a corona rapid test, and to send us the results if it is positive or negative. The swab should be taken a day after symptoms started. I just wanted to make sure that there is enough antigen so that the test becomes positive. And initially, an antigen detection test within the first 24 hours may certainly be negative because there is not enough of the organism. So why? And I think it becomes clear now from what I said already, acute respiratory tract infections, they all look roughly the same. There are some specificity. For example, adenovirus induces a lot of conjunctivitis, also pharyngitis and lymphadenopathy at your neck. So that is a diagnosis you can make clinically. If I see a patient with a specific symptoms, I can say very likely this is an adenovirus infection and I don't even need a test. But many patients or many doctors don't have that experience, I guess, and they would like to have laboratory confirmation. And in the past, this was not possible due to technical requirements, due to costs and legal restrictions. And largely, if ever, diagnosis by laboratory confirmation were only usually done in hospitals, rarely in private practices, and largely they were done in certified medical laboratories. For this reason, the true burden of diseases caused by artiparagen remains largely unknown. And even more than that, the data available are largely biased because of circular reasoning. We usually test only those subjects who are at high risk for complications. A young man who just comes in and seeks to get his sickness signature so that he can take off from work will never be tested because he has no risk to be hospitalized or very little risk to be hospitalized. He won't have any complications, so why test him? And for this reason, all the epidemiology data we have on these non-colonizers is biased by pre-selection criteria if it only be medically attended. Nobody tests other than the first slide I show you with the American Army, where they looked at respiratory tract infection before medical attention. I guess usually in most of the countries, we only start looking after or with medical attention, not before. And this is why we really do not know much of the epidemiology of respiratory tract infections of these very common non-colonizers. Our MAC5 we're using right now can detect SARS coronavirus 2, influenza A, B, RSV, and the adenovirus. We did not select this. I chose this test because they have the most antigens and the most relevant distribution. For SARS-CoV-2, we have treatment and there is a vaccine. There are many vaccines actually. For influenza B, there is A and B, there is treatment and there are vaccines. RSV, there is now a vaccine or several vaccines. There are tons of vaccine candidates out there to be licensed this year and next year. And finally, adenovirus is here. There is no vaccine, but it is very important for differential diagnosis of pharyngitis. It causes severe pharyngitis. Ideally, I would delete adenovirus and add Streptococcus A, Streptococcus pyogenes, because that is an indication, if it is positive, for penicillin treatment. And I would also add as a sixth pathogen, rhinovirus, because rhinovirus is the very most common ARI pathogen. It's probably 2 or 3 times more frequent than influenza A. And that should be in the test. So this is what we have right now, nevertheless, and we're working on something that is even better in the future. How does it work? The multiple antigen test kit with 5 antigens has this test card, sample extraction tube, a tube cap. It has an anterior nasal swab, and it has a waste pack, which I think is very Chinese. And this is funny that they have this. I couldn't believe it when I saw it. I have to admit, I never had a test kit in my hand. We sent everything to the Cologne Center, and I never had one in my hand. And some of those attending today's session probably have packaged them, and you know more than I do. In any event, you take your swab, you put it in this tube here, you stir it around 5 times, you squeeze it 5 times, you close the tube, and then you put up the top cap and you can add a few drops on the test card. And after 5 to 15 minutes, you read the results. Always the C stands for control, has to be positive. If there is no C, you cannot interpret the test, and whatever the result, it's not valid. This test result on the left side, upper side is Corona COVID-19. This is flu A, here flu B. Here we have the control on the lower bottom, and it is adenovirus, and this is respiratory syncytial virus. Here we have now multiple detections. What you see here is flu A, B, and COVID, and what you see is flu A and B. That is the simple reading. I would expect from our multiplex PCR diagnostics over more than 10 years that roughly 14% of detections, up to 14%, should be double infections during the season. Now, the first results that were kindly provided to me this morning, thank you to Julia and whoever else worked behind this, I'll show you in the end. Thanks for these results. This is a little bit incomprehensible or difficult to look at, so I just want to show a little bit of the graphical results here. This is from week 49 last year to week 8 this year, and you certainly see here in this pink color the coronavirus, SARS-CoV-2, and it goes up again since week 6, and I just got confirmation. This is the Cologne Carnival season, right? And this is the fire of the epidemic. If you want to have Corona, join the Cologne Carnival. And I've never seen this for any pathogen in all my life, that it goes up, that it goes down, then goes up again, and then you have certain waves like here. I've never seen this for any pathogen. This is very unique, and it shows you the specificities of the coronavirus to escape immune mechanisms. I've never seen this with any other organism. And I think nobody ever has described this, that you see these multiple waves in this detail. And again, this is not patients in medical attention. This is patients who not necessarily went to see their doctor. At the time they did the test, they probably did not see any physician. So this is SARS. Now we have here in blue influenza A, you see the winter peak here, and then it goes down and it wanes. There is a little bit of influenza B, which should be down hidden here. There is not much of influenza B. We only had a few cases here in this system, but look at RSV in green. RSV may be even more frequent than influenza, and this is largely or more than 90% adults. RSV is an adult disease, and the only reason is we believe that it is a pediatric disease is only children are hospitalized because they suffer from bronchiolitis. 75% of RSV hospitalizations in childhood are children in the first 6 months of life. Adults are never sick enough to seek medical attention, let alone any testing. There is no good data from any country on RSV in adults. But you see here how frequent it is. This is here, this is very often more frequent than influenza, and not much known about it. Most people even out there in Germany and in Europe have not even heard about the respiratory syncytial virus. But again, it is here, I guess, at least 50% of the infections that were detected by MUC5 so far. We can get more data. I don't want to go into this. I just want to show you the opportunities that we have. We have now data on prior vaccination. We can look into vaccine effectiveness with the system. We can look at underlying diseases that are listed here, and you see here 66 of these had high blood pressure, and so on and so forth. You can go down the list, which I don't want to do here. Much you can do now with this test, and again, the beauty of this is data before any medical attention. And that is why this is largely so important. Now, in the future, what we want to do, hopefully next season, we want to send 4 test kits to 5,000 representatively selected subjects of the volunteer registry. They will receive weekly mails to confirm that they had no ARI, because this is equally important if you want to calculate incidence of respiratory tract infections. And we want to remind them to use the MUC self-testing 12 to 24 hours after ARI symptoms first develop, using in the respective season. There will be a barcode on the test package, and that will lead you to the website where you can register. Those who are participated are registered already, and then they can enter their data. In the end, they can enter the test result and even upload a photo. There will be reminders to ensure completeness of information. The data will be anonymously analyzed, including simple descriptions and all the statistics behind it. The data will be made available on a weekly basis, and the data protection laws will be certainly implemented here. In summary, ARI pathogens are the most common diseases in humans. It is important to distinguish between upper and lower respiratory tract infections, and to be reminded of the 14 non-colonizing pathogens. The burden of disease in ARIs is biased currently and towards more severe courses and to patients at risk. The MUC5 test for the first time would allow us unbiased population-based testing, and the opportunities are manifold, including real burden of disease data, detecting rhythms, patterns, efficacy, effectiveness of various interventions, transmissions patterns, predictions of epidemics, weather implications, and much more. I would like to thank all these people here on the slides, and specifically Julia, Yannick, John, Sarah, Pauline, and Janina, and all these who are working, let me say, in the back office. And without all of these people, these data and this study would not have been possible. Thank you very much, and I'm here now for questions. I guess I can see questions in the chat.
We have one question in the chat regarding the tests. Evelyn de Porter asked if the tests were developed by the Uni of Cologne.
The test was developed, actually who it first developed, I don't know. But the current test we have is from a Chinese company. It is a simple rapid, I mean, this is no secret anymore. Rapid testing has now become very common ever since COVID, right? And such tests have been available from a variety of companies. I know of 4 companies who produce multiple antigen detection tests, but the one we have is the one with 5 antigens. And I hope as of next seasons, we're going to have 6 antigens. And that's the reason why we chose this one. Any other questions, Julia?
So we have another question from Oliver Cornely. Is there a limit to the number of antigens we could add?
The answer is, for technical reasons right now, yes. For the system we are using, it is probably 6. In the future, the answer would be no. The problem is you have to start all over again with developing a test for more antigens, because you would need a higher volume in the test tube. And that means that you have to recalibrate all other reagents. So in principle, instead of 1 test part, you can use 3, 4, 5, 6. But that means the sensitivity may go down a little bit if you just dilute your sample that you take. So you need, for certification purposes, you need a whole new development process, and that is time consuming. So I guess the answer is very soon, 6 is the limit, I guess, for this system. But in the end, there is no real limit. And again, it would be nice to have all roughly 20 organisms, including pertussis, in the test kit. In the end, I think for clinical reasons, it would be nice to have 6, and then have 1 complementary, and then 1 for the hospital to diagnose Mycoplasma, Chlamydia, pertussis, and Legionella. Julia, I think this is it for the questions. I don't see any other in the chat. If you have any other questions, let me know. If you have any questions, write me an email, happy to address it. I just see Zoe was writing, very important initiative. Hopefully Cyprus vaccination will participate in the next autumn. We will think of you, Zoe, and most importantly, purely participatory science for the EU citizens engagement. Thank you very much. From my side, thanks you for your attending, and thanks for your time and for your interest, and hope to meet you again at another webinar. Do not miss our next VACCELERATE webinar on Monday. Janina, I'm not sure, you want to say some words in the end?
Definitely. Thank you so much, Joe, for this very, very interesting presentation. I think we enjoyed that very much. We recorded the webinar, and within the next days, you will be able to find that on our YouTube channel as well. As Joe kindly already mentioned, on next Monday, we're having the next VACCELERATE webinar. We'll be very happy to see you there again. And if you have the chance to put up VACCELERATE Volunteer Registry posters or disseminate flyers, very happy to take your orders. We put the order form in the chat, or if you need anything, just write us a short email. Thank you very much, and enjoy the rest of your day.